So I guess I'll go ahead and get started then. Thanks, guys, for having me. It is the morning over here in Austin, Texas, but good afternoon to y'all over in the UK. My name is Darren Nattinger. If y'all don't know me, I am a longtime NI employee. It'll be 25 years for me next month. And I currently work in the tech support organization, helping our tech support engineers support our LabVIEW customers better. That's basically my job right now. But for almost 20 years before my current role, I worked in LabVIEW R&D, and I had the unique privilege of being a LabVIEW programmer in LabVIEW R&D. So I sat alongside all the C++ programmers who were adding features to the LabVIEW source code. I was adding features to LabVIEW that were written with LabVIEW. So I wrote Quick Drop, I wrote the VI Analyzer. I worked on almost every one of the APIs that ships with LabVIEW. Report generation. I worked on App Builder some. So I've had my hands in a lot of the LabVIEW-based parts of LabVIEW. And today I'm going to be talking about, you don't even have to wait for LabVIEW R&D. You can write your own LabVIEW features. So in this presentation, I'm going to cover every single possible way that you can augment the LabVIEW editor with G code. But before I get started, I always like to point out that all of my presentations are available online already for anybody to download, and you can grab them all at dnat.org. All of the slides, all of the demos, links to video recordings of the presentations, all available there. And you can see in the slide there, I've got this presentations link as well. Feel free to go there and download the slides now if you'd like. There are lots of links in the slides for, to go visit ni.com to grab more stuff. So you could be navigating to those while I'm presenting. That's totally cool. But yeah, so dnat.org, that's where you can get all those things. One thing, let me see if I can get the chat window up on my other monitor here. That way, if you guys have any questions while I'm presenting. Cool. Okay, so I'll be watching the chat on my other screen. If there are any questions, feel free to post in there. And also, you can unmute your mics and ask me questions during the presentation as well. But here's a general outline of what I'm going to be talking about. Since I'm talking about writing your own LabVIEW features with LabVIEW, the first thing you need to know about that is VI scripting. That is a feature in LabVIEW that lets you write LabVIEW code that edits or inspects LabVIEW code. So we kind of need to talk about that before we get into the actual editor hooks that you can use scripting with to add features to the LabVIEW editor. And you can see here a list of the things I'll be talking about, like quick drop plugins, right-click plugins. And then at the end of the presentation, I am going to talk about Rusty Nails. So at the beginning, when I said I'm going to talk about every single possible way to hook into the LabVIEW editor, I'm totally serious. I'm going to mention every single one, including the ones that I don't think you should use. And that's going to be the section at the end. But first, let's talk about scripting. So if you are at some point going to write your own LabVIEW features, you have to use VI scripting. So what is VI scripting? VI scripting is just VI server with more stuff. That's literally all it is. So we're familiar with VI server, right? We've got properties and methods. We've got classes like control class and decoration class and things like that. And we can operate on those classes in VI server. We've got properties to manipulate things on the front panel. We've got properties to manipulate VIs. We can even interact with the project window. We can get references to project items in the project window and do things with them. That is VI server. Well, what is VI scripting? Exactly the same things. There's more properties and methods for front panel objects. There's more properties and methods for VIs. There's more properties and methods for projects. But we also, with VI scripting enabled, get the ability to manipulate or inspect block diagram objects. So if you look at the picture at the top, you see that that code is grabbing a reference to a control in the front panel and changing its visibility. The code on the bottom looks very similar. It is grabbing a reference to a while loop on the block diagram and then adding a shift register to the border of that while loop. So you can see the manner in which you code, the way that the code looks, very similar between VI server and VI scripting, again, because they're the same thing. Throughout this presentation, there will probably be more points where I mention that VI that's sitting on that block diagram. That is a hidden gem. If you've never seen it before, it's called tref, find object by label. It is the easiest way to just get a reference to an object on your front panel or on your block diagram if you know what its label is. And you can see a link there in the slide to my hidden gems presentation, which is another one of my pieces of content that relates to really useful VIs that ship with LabVIEW, but they are not officially supported by an I. That's the tref find object by label is an example of that. So this is what VI scripting is, just VI server with more stuff. Now, how do you turn on VI scripting? It is a tools options setting. So go into tools options, VI server. There are a couple of checkboxes under the VI scripting section. If you check those mainly give you access to two new things. One is new objects that you can drop. I guess three things now that I think about it, one I don't mention in the slide. The first thing is that palette of objects that you see there, like things like new VI, new object, traverse, etc. And the second thing that you see there is whenever you're working with scripting, a lot of the times you need to identify terminals on objects. And when you enable scripting, the second checkbox in the tools options there, you'll see those indices that tell you, if you want to gain access to this terminal on this node, then you would pull out index whatever from the list of terminals. And the third thing that you get that I've neglected to mention on the slide is a bunch of new properties and methods, like I mentioned previously. We got a question in the chat here. tref in the name, is that to improve the quick drop support? No, tref in the name is because I wrote that VI so long ago, I'm pretty sure we didn't have libraries in LabVIEW yet, so there was no namespacing. That's why it has tref in the name. Got to prefix those VI names back in LabVIEW 7 days. Okay, so this is how you enable VI scripting. Now, what happens when you enable VI scripting? Well, check out this G-object hierarchy. So if you've ever worked with VI Server, you know that one of the classes in VI Server is G-object. And basically anything that is a panel or something that sits on a panel, or a diagram or something that sits on a diagram, those are all G-objects. Well, without scripting turned on, your G-object hierarchy in LabVIEW is going to look like what you see there on the left. You've got panel, pane, splitter, control. Under control, you've got all the different control types, decoration. As soon as you turn on VI scripting, the G-object hierarchy gets a lot bigger. Now you can browse and see all the same stuff on the left, but now you've got the diagram class, the wire class, the terminal class. You've got the node class. Under that, you've got functions, some VI structures. Under structures, you've got loops, et cetera, et cetera. So whenever you enable scripting, that hierarchy whenever you're browsing the hierarchy of objects becomes much larger. So how can you learn VI scripting? If you've never written code before that uses scripting to manipulate or inspect VIs, how can you learn it? There's multiple ways. First of all, there are several shipping examples for scripting, and we've got the path to the examples there in the slide. There are several LV projects there in the VI scripting folder that have top-level examples that illustrate things like navigate, all the interesting properties about structures, or how to create a node and wire to it. Those are examples that we have in there, that are in there, and there's a whole bunch more too. There's a VI scripting tutorial in the LabVIEW help, and that's kind of a guided way to go through the scripting examples that I listed in the first bullet. And then the way I would suggest learning scripting is to browse the features that use it. So quick drop plugins, right-click plugins, VI analyzer tests, those are all things I'm going to talk about throughout the course of this presentation. And these are features that I personally have worked on a lot. And what I've tried to do is leave the block diagrams of those open as much as possible. I've tried to password protect very few things in those folders that you see there, so that it is easier to browse the code of those features and see how they use VI scripting to accomplish those tasks. All right, so I am going to do a demo for scripting. I am going to write a new LabVIEW feature before your very eyes. Now, normally, y'all, I have a demo that I've already prepared for this part of the presentation. I've done it a million times. I normally go through the same thing, but hopefully today is going to be a little more interesting, because just a few days ago, somebody brought to my attention sort of a gap in the functionality of the LabVIEW editor, and I thought to myself, wait, I should just fix that myself. I should write a feature for that. And then I thought, well, wait a minute, I'm giving the presentation to the user group in a couple of days. Why don't I do that feature for them as part of the scripting demo? So I'm going totally off script, haha. I'm going to implement a new LabVIEW feature for y'all that I have not done before. So this should be fun. Let's see how much I can screw up during this demo. So let me switch over to LabVIEW, and I'm going to show you guys the problem that I'm trying to solve. So I was working on some code where I had a for loop, And I had a bunch of arrays that were going into the for loop. So something like this. And so these guys were all going into this for loop like this. And then I also had within the for loop, I was going to have another for loop. And in that for loop, I was going to have some code that was generating arrays of things. And so it kind of was going to look, I guess I can make those wires first, so I don't have to wire them every time. So it's going to kind of look like this. So this is the code that I was writing. And here's the problem. I needed to pass these arrays into this inner for loop as arrays. Well, as you can see, LabVIEW automatically turns on indexing for those tunnels, and I don't want indexing on those tunnels. So I would have to right click and disable indexing on all four. And I thought, wait a minute, I'll just multi-select them and right click and disable indexing. And that's the first thing that frustrated me with LabVIEW, is that it didn't change them all, it only changed one, even though I had them multi-selected. And then I realized, well, with these arrays over here, I actually need these to be concatenating. And there was going to be a condition that was going to concatenate them conditionally. So I needed to change all of these tunnels to concatenating tunnels. So I would select them all, right click, tunnel mode, concatenating. Well, once again, it only changes one of them, so I'd have to change them all. And then the same thing, I'd want to do right click and make them conditional. And again, it only changes one of them. So I thought to myself, I need to write a LabVIEW feature that lets me change those things with one click. And my first idea was I could make a right-click plugin for this. But then I thought, well, even then I would need two right-click menu options. The first one that would change to concatenating, and then once again, another one that would change to conditional. So I thought, what is the fastest thing I could do to change a bunch of tunnels at once and change multiple properties on them at once? And I decided I'm going to write a quick drop plugin to accomplish this task. And so what I'm going to do right now is write the feature that does this. So I'm going to create a new quick drop plugin. And I'm going to go through this kind of fast. Don't worry, as I go through the slides, there's going to be links. When you download the slides, you can get links on all the things on how to do this. So let me save this quick drop plugin, and we're going to call it configure tunnel mode. And that is also going to be the name in the undo stack, configure tunnel mode. And I need to make a description for this plugin. So let's say I am going to say configure tunnel mode with the following parameters, because I'm going to read what text you type into the quick drop window in order to know what to change the tunnels to. So let's say that how about L is last value, I is indexing, C is concatenating, and a question mark is conditional. And I need to make a default shortcut for this. I happen to know that C is not currently used, so I'm going to use that. All right, now I'm going to look at the diagram. There's a whole bunch of crap going on here. If you've never written a quick drop plugin before, you probably should read all this stuff, but I've written a few, so I'm just going to delete all these comments and get rid of all this stuff. And okay, so what do I need to do? I need to write some scripting code, right? Just talked in the presentation about how we need to write scripting code to write LabVIEW features. So what I'm going to do is I'm going to take whatever is in the selection list, and I'm going to cast it to loop tunnel. Now, these are things that I happen to know because I've written lots of scripting code. If you didn't know these things, you would have to right-click, select VI server class, generic, G-object, tunnel, loop tunnel. You'd have to know how to go to all that stuff. And the more scripting code you write, the more you learn about all those things. So the selection list might have things in it that are not loop tunnels. And so if it does, we just kind of want to not do anything. In fact, I'm just, for the purposes of the demo, I'm just going to do no error handling here. If we ever do find something that's a loop tunnel, we are going to need to change it to match whatever the person typed in, and then set an undo transaction to say you can undo this thing if you want. So for the loop tunnel class, we've got a couple properties. We're going to set the index mode, and we're going to set whether it is a conditional tunnel or not. And if we look at the context help for index mode, it is no help whatsoever. It says gets or sets the indexing mode of the tunnel. How do I know what value to set there? We look at the more detailed help. We see that 0 is regular, 1 is auto index. This version of LabVIEW, they did not update the documentation to tell us that 2 is concatenating, but I happen to know that. So now what I need to do is I need to read what was typed in the quick drop window, and that's this reference here. So I'm going to do text to get the value in the quick drop window. I'm going to split that into 2 characters like this. And if the second character that is typed in is a question mark, then we are going to say that that means they want this tunnel to be conditional. And the first character that's typed in, what did I say? I think I said C is, or no, I said L is last value. So we're going to put a 0 there. And we're going to say, I believe it was I and C. And we're going to turn off case sensitive matching. And we're going to delete this case. And we're going to make this one the default. And we're going to say that indexing is 1 and concatenating is 2. And unless I missed something, I just finished my LabVIEW feature. So let's give it a try. So we're going to go back to the VI. And all of these guys, I don't want indexing on. So I'm going to press Control Space. I'm going to type an L, and I'm going to press Control C. And you can see that that changed all of those tunnels with one click or with one key press with my keyboard shortcut. Let's close this here. These guys, I wanted all of these guys to be concatenating and conditional. So if I select all of those, type in C question mark and press Control C, which is my new feature, it changed them all to concatenating and conditional with one key press. I just implemented a LabVIEW feature for an editor thing that I wanted. And what did that take me? About 5 minutes. And now I've got this new plugin in QuickDrop. If I don't like the key of C for it, which was set here as the default, I could change it to something else. You can see I've got lots of plugins installed. But that's basically it. So that was me writing a QuickDrop plugin to add a feature to the LabVIEW editor with G-code using scripting. I'm going to go into a little bit more detail about the different types of hooks like QuickDrop plugins. Are there any questions on anything y'all saw before I continue with the slides? All right, sounds good. Let me switch back over to the slides. So the normal demo that I do for this presentation, the normal canned demo that I've done a million times, is for a QuickDrop keyboard shortcut called Nattify. So I wrote this plugin and posted it to ni.com. You can see the link there in the slide, to give myself a way to basically undo all the stuff in a VI that I don't like. So if somebody else writes code and they give me that code, one of the first things I do is when I open their VI, as soon as I see something I don't like, I press Control Space, Control N, because that will do all the things that you see in the slide here. Turn off auto air handling, turn off auto grow, turn off terminal view on controls and indicator terminals. I can go on and on. But this is an example of a way that you as a LabVIEW programmer can augment the LabVIEW editor to improve your own developer experience. I wrote this plugin because I was tired of getting code from people that had auto error handling turned on and subdiagram just label justification set a way I didn't like. So I wrote this feature, published it on ni.com, and people seem to like it because on the thread for the shortcut, people have been uploading tools that wrap the Nattify tool to like Nattify an entire code base with one key press. So you check that out, bit.ly/Nattify. I see a question in the chat here. Can a QuickDrop plugin be triggered by a command string in the QuickDrop search field instead of a keyboard shortcut? So the question is, as you're typing in QuickDrop, can something happen in the text field that would cause a plugin to execute? The answer is no. The way that QuickDrop is currently written, you must press Control and then a key in order to execute a QuickDrop shortcut like the one that I just implemented during my demo. All right, so let's talk about some best practices for scripting. One good best practice is to not slap your code together as fast as I did in my demo, but to pay a little bit more attention to your error propagation. But a few other things. You want to, when you're writing scripting code, you want to script as few new objects and wires as possible. So if you're writing some sort of tool that is generating a VI or generating a chunk of a block diagram, that would be different from the one that I just wrote. The one I just wrote is tweaking some settings on some diagram objects, tunnels. What if you're writing some scripting code where you want to generate code? A good best practice is to script as few new objects and wires as possible. And one of the ways you can do that is start with a template. So just thinking about tools like DQMH and Actor Framework. Those are two tools that have a bunch of developer tools built into them. And for example, in Actor Framework, there is a way to right-click in the project and create a new message for an actor method. And that scripts new VIs for you and creates block diagrams that have class constants and 2 more specific class and a sub VI call and a case structure. You don't want to be scripting all of that stuff from scratch. You want to start with a template. And then you want to tweak that template with as few changes as possible. So that's my first suggestion for best practices. The next best practice, if you have labels on objects in your templates, you can easily find them with that VI that I talked about earlier, tref find object by label. That way you don't have to parse the whole block diagram to find this one constant that you need to change. Just label that constant with a certain label that you know you're going to be able to find. Look for that and then do something to it. If you do have scripted code that your users might, or that people might be looking at, for example, again, going back to the actor framework and the DQMH example, both of those frameworks will script template-based code into your project. And so presumably you're probably going to be opening VIs that DQMH or actor framework scripted. The easiest way to make sure people don't mess with crap is to just put a comment in there that says, don't modify objects that have a label like this. All of the DQMH scripted VIs have a comment on the diagram that says, if you see an object with a label that starts with DQMH, don't mess with it. Otherwise, you'll break the scripting. And then my last piece of scripting best practice on this slide, there is a function in scripting called Open VI Object Reference. Whenever you turn on scripting, you will see that function sitting on the scripting palette. Never use that function. It doesn't work the way you think it will. If you have a nested object on your block diagram, you would say, oh, hey, I know the label of this thing. It's sitting inside of a case structure. Let me call Open VI Object Reference to get a reference to that thing sitting inside the case structure. It won't work because Open VI Object Reference doesn't look inside of nested objects. tref find object by label does. So never use Open VI Object Reference, even though it's sitting right there on the palette. Also, the examples when you go through the scripting tutorial are going to use that function a lot. Just ignore that. Use tref find object by label. Similarly, there is a function in the scripting palette called traverse for G objects. Always use that when you are looking for, like, let's say you need to find all of the property nodes on a block diagram because you need to do something. Use traverse for G objects to find them. There are a couple of properties in scripting, like the controls property and the all objects property. You could get like all the controls on the panel or all the objects on the block diagram. But again, those properties don't recurse into nested objects, whereas traverse for G objects does. So make sure to use that whenever you need to find everything on a block diagram, even things inside of nested diagrams. I see a question in the chat. If a quick drop plugin matches another plugin, which quick drop plugin will take preference regarding the key shortcut? I am pretty sure it's, well, the first thing we do is we look at any custom assignments that you've made. So if you have assigned a plugin a keyboard shortcut that's different from its default, that one will take precedent. After that, we look at the default plugin letter for a shortcut. And if there's still a match, honestly, it's probably just the first one that shows up alphabetically in the list. All right, more best practices. So this is something that kind of makes me chuckle a little bit. We always try to close references in LabVIEW, right? If you have a DACMX reference, you got to close that when you're done. If you have a file reference, you got to close that when you're done. If you have a G object reference in scripting, you never need to close it. In fact, when you tell LabVIEW to close the reference to like a control on the front panel or a wire that you've gotten a reference to through scripting, if you call close reference on that reference, LabVIEW does literally nothing other than occupy space on your block diagram with that close reference function. You do not need to ever close G object references. I talk about this topic in my Brainless LabVIEW presentation. Link is there in the slide. But save yourself some time. You may have even noticed that if you were quick enough, when I did my demo earlier, there were a couple of close reference functions that were part of the quick drop plugin template that I just immediately deleted when I started the demo. So you never need to close G object references. Another best practice. So scripting is fast. There have been sort of, I guess, some falsehoods that I've heard in the past, people talking about I don't like to write scripting code because scripting is so slow. Scripting is actually really fast in terms of inspecting diagrams, modifying block diagrams. Most of the scripting applications I've worked on, the thing that takes the longest time is in terms of the whole scripting process is opening a reference to the VI that you want to script into. That is the thing that probably takes 80% of the time. The remaining 20% is the actual scripting that you're doing. So loading libraries, loading classes, loading VIs, the part at the very beginning before you even get to the scripting, that's usually what takes the longest. One exception is gigantic block diagrams. So there's something in LabVIEW called type propagation, where if you make a change to a block diagram, LabVIEW basically scans the entire block diagram to see if any data types need to change. It's one of the great things about LabVIEW. We've got a strictly typed block diagram. We'll get broken wires if we have types that don't match. But part of that is since LabVIEW code is compiled as you edit it, every edit is going to have type propagation go across the block diagram. Type propagation's pretty speedy up until the point that you get gigantic block diagrams, at which point it kind of bogs down. And you might even notice this in the, you might even notice this in the editor when you're just editing a large block diagram. You might, just to change wires or change positions or drop objects, you might find that that takes long. That's because of type propagation. Same thing with scripting. If you've got a very large diagram, type propagation is going to slow things down. But in general, normal size block diagrams, normal size VIs with front panels, scripting is going to be fast. The opening of references is going to be the slowest part. And then this last one's a biggie. So cross-context issues. Whenever somebody says the word context in LabVIEW, they are referring to an application instance. And if you don't know what an application instance is, it is basically the place where your VIs are edited or executed in terms of what target they are running or targeted for. So my computer is an application instance. Your RT target is an application instance. Your FPGA target is an application instance. If you have a VI open with no project open, there is an application instance called main application instance that runs in. But all of these G-based features that I'm talking about in this presentation, quick drop plugins, right-click plugins, all of those things, they run in their own private editor application instance. So there's all these application instances flying around. If you're running a tool like a right-click plugin in one application instance, and you have references to objects in a VI that are under my computer, and you start doing things across those application instances, that can cause some issues. It can cause things to lock up in your project. In some weird cases, it can cause crashes, which I'm going to talk about later in the presentation. The thing that you want to do, if at all possible, is whatever application instance your VI normally resides in, which is usually my computer, although sometimes it's RT targets, FPGA targets, make sure that whatever scripting you're doing is operating on those VIs in the application instance they normally reside in. So many times people are having issues with their scripting tools that are running in other contexts or application instances. This is the cause. And then my last best practice idea, if you are learning scripting, if this is all pretty new to you, there's a tool that Norm Kirchner, my colleague at NI, wrote. It's called the Scripting Springboard. It is an easy way to get started doing stuff with scripting and experiment. It also comes with a few built-in features for the LabVIEW editor. So again, augmenting the LabVIEW editor with scripting. There's a neat feature in there, for example, called Smashy Smashy. I'm not going to tell you what it does. You're going to have to go download Scripting Springboard and find out. But it's a cool feature to add to your LabVIEW editor. All right, that was the scripting background, over almost half the presentation. Now we're going to get into every single possible way to hook into the LabVIEW editor with G-code. And the first one we're going to talk about is one you've already seen. I just did a demo of it, quick drop plugins. So when quick drop is open, when you've pressed Control Space, normally you use it to drop objects on your VI, right? You type the name of an object, you drop it in your VI. Well, while quick drop is open, you can also press Control key shortcuts like I did in my demo to implement a scripting-based feature. For example, the one I just wrote in my demo was changing tunnel configuration options. The one that you can see in the slide here is where you select objects and press Control Space Control D, and it will create controls and indicators off of the terminals of those objects. There's a bunch of other quick drop plugins that are really useful. When you bring up quick drop, when you press Control Space, click the configure button in the bottom corner and go to the control key shortcuts page, and you'll see all of the ones that ship with LabVIEW. and any ones that you've downloaded or installed as well. You're going to want to use quick drop plugins for frequent repetitive editor actions, things that you're doing multiple times a day. For example, I think the quick drop plugin that's probably the most popular, the one that people like the most, is remove and rewire. So select one or more objects on your diagram, Control Space, Control R. It's going to remove those objects from your diagram and preserve pass-through wires on those objects, as opposed to deleting the object and having to fix the wires yourself. That is a frequent, repetitive thing that you do multiple times a day when programming in LabVIEW. And the slides have a link to how to write your own. You guys saw me start with a template and kind of blaze through writing one. Obviously, if you've never done it before, you're going to want more instructions. The link in the slide has documentation on how to do that. There are over 10 plugins that ship with LabVIEW. For example, remove and rewire, create all controls, those all ship with LabVIEW. There are over 50 plugins available on the QuickDrop community that you can download, and that's at ni.com/QuickDrop. Now, one of the things I want to do in this part of the presentation is I want to show an example of scripting code for the feature, and then I want to talk about some weird thing about that scripting code. That's what I'm going to do for this section of the presentation. So this scripting code that you see here on the block diagram is the code for wire all terminals. So if you select a function, Control Space, Control D, we're going to create controls and indicators on all the unwired terminals for that function. So if you look at this code, you'll see that we are taking the terminal reference. If it is not wired, then we're going inside of that case structure. And if it is a source terminal, we are going to create a control. If it is an indicator terminal, we're going to create an indicator. So that's what this scripting code is doing. What in the world is a hidden terminal? You can see that this code is checking, is the terminal hidden? And if it is, then we will not create controls or indicators. Well, again, this is the part of the presentation where I talk about weird things in scripting. A hidden terminal is a terminal that has been designated by some part of LabVIEW as being something that users won't see. For example, the timed loop. You can see a picture of the timed loop there. It's got the ears on the outside, looks like Mickey Mouse. It's got the ears on the inside. Well, under the hood, you can't see it, but there are terminals connecting those ears of the timed loop to the timed loop itself. And those terminals are called hidden terminals. So I don't want my scripting code to mess with those at all. I don't want to do some weird thing to my timed loops and break them or whatever. So I'm just going to ignore hidden terminals. So that's an example of one of those weird idiosyncrasies of scripting that you have to watch out for. Next up, we're going to talk about right-click plugins. So this is a way for you to write G code to add items to the right-click menus in the LabVIEW editor. For example, in the slide there, you see a list box, and there is a delete all rows item in the list box in the right-click menu that will just wipe out everything in the list box. When I first learned LabVIEW in 1999, it was LabVIEW 5.0. I was taking the LabVIEW Basics course. We were talking about front panel objects. They were telling us about list boxes and rings and all that stuff. And I had a list box and it had some stuff in it. And I said, hey, how do you get rid of all the things in this list box? And whoever was the instructor said, oh, well, there's not a way to do it on the panel. You have to write code to empty your list box. And I thought, well, that's dumb. Well, 20 to 16 years later, I got right-click plugins in LabVIEW, and I was able to, in about 20 minutes, write a right-click plugin to add the feature that I wanted 16 years ago. So yeah, so that delete all rows item you see in the list, that is a right-click plugin that is written with G code. Now, right-click plugins, when do you want to write those? You want to write those for context-sensitive editor actions. So you want to write those where it is a thing that you want the menu to only show up for that thing. For example, I could have written delete all rows as a quick drop plugin, but do I really want a key press to be something that operates only on list boxes? No, that doesn't really make much sense. Now, your first question might be, didn't you just do a demo where your quick drop plugin only operated on loop tunnels? Yes, I did, but quick drop plugin is way easier to write than a right-click plugin, and I didn't want to take too much time out of my demo, so that's why I did it that way. But if I were doing my previous demo, for a more, I guess, formalized setting, like a feature that's going to ship with LabVIEW, probably would have done that as a right-click plugin instead. Again, there's documentation for writing your own right-click plugins. There are over 30 that ship with LabVIEW. So we added this feature in 2015. It's 2023 now. We've got over 30 right-click plugins that are part of LabVIEW, over 80 that are available to download at ni.com/lvmenus. And there's also a presentation that's there that Stephen Loftus-Mercer and I gave. He and I worked on this feature together when we were both in LabVIEW R&D. And we gave a comprehensive presentation on creating your own right-click plugins. So again, here's some sample scripting code, and let me demo what this feature is. So let's see. So let's say you have, I'll just make a new VI. Let's say you have an add function, and let's say you have an array wired to one of its terminals. If I right click on this other terminal and do create constant, I get an array constant. What if I don't want that? What if I want a scalar constant? Well, if I right click and do create, you can see scalar constant is one of the options in the right click menu, and it makes me a scalar constant. That right click menu option to create a scalar constant. So one more time, create scalar constant. That is a right click plugin that is providing that menu option. So here is the code for that right click plugin. The code on the top is what populates the menu. The code on the bottom is what actually does the scripting. So just to summarize real quick, the code on the top checks the right-clicked terminal to see if it is an array. And if it is an array terminal, we add the scalar options to the right-click menu. The bottom code is getting the data type of the terminal, getting the type of the element of the array, and then creating a constant of that type and connecting it to the terminal. So that is the sort of the two parts of a right-click plugin: populating the menu, doing the scripting. Again, a weird thing in this code. What in the world is that function that's sitting right there in the right-click plugin code? That is a request deallocation function. What is a request deallocation function? The code that you see here is just about the only time I've ever used request deallocation. So again, talking about weird things in scripting. Reading the data type property of a terminal is kind of risky in LabVIEW because have y'all ever noticed how if you have a LabVIEW class and it is in your My Computer, for example, and you try to, and that same class lives under another target, like an RT target, and you try to do anything with that class and it's locked. The LabVIEW editor doesn't let you do anything with that class because it is open in two different application instances. Well, the project editor keeps you from doing that, but in scripting, there's nothing stopping you from gaining access to LabVIEW class data across application instances. And unfortunately, in scripting, if you do that, sometimes you'll crash. And so what happens with these right-click plugins is, if you ever call the data type property, you should probably call request deallocation. That is your best chance of telling LabVIEW, hey, I don't want you to keep data, I don't want you to keep references to data open across application instances, especially if that data type has a class in it. So request deallocation is basically you telling LabVIEW, please don't crash when you run this code. And LabVIEW usually will say, okay, I'm not going to crash. Sometimes it does anyway, but this is a pretty safe way to prevent it. So that is one of the weird things about right-click plugins. Basically, any right-click plugin or any scripting code really that you see that has a data type property on its block diagram, you're probably going to see that request deallocation function call as well. Pretty weird, huh? All right, let's talk about pull-down menu plugins. So these are plugins, G-based plugins that you can put in the pull-down menus of the LabVIEW editor. So usually they're in the tools menu, but you can also sometimes find them in the help menu and the file menu as well. All of the menu options that are shown in the red box in the slide are actually implemented as G-based plugins, so written with LabVIEW. Again, we have documentation on writing your own. There is a link in the slides on how to do that. Now, when would you write a pull-down menu-based plugin? I can think of two reasons. One is if you want to do something that's environment-based, like you want to just launch a new tool. For example, you can see in the picture there, we've got the web publishing tool is one of the things in the list. We've got the find VIs on disk tool that's in the list. Those are examples of things that are just a new tool that you want to launch. So it's pretty easy to launch that from the tools menu. Another reason you would want to have a pull-down menu plugin is for a document-based action. So if you want to do something with the current VI whose menu you are launching this tool from, then that's an example of when you might want to use a pull-down menu plugin. For example, the one on this slide here, which is a pull-down menu plugin called Explore. What all this does, this does not ship with LabVIEW, by the way. Somebody wrote this and published it on ni.com. What this does is when you go to Tools Explore, it just opens up a Windows Explorer window with the folder that has this VI in it. That's what that does. So that's pretty useful, right? Well, there's some kind of weird things going on this block diagram. The first one is that VI there. What is that VI that's sitting at the very front of that block diagram? That is just a utility VI. If you ever write pull-down menu plugins, you're going to need that utility VI because it gives you a reference to the application instance that your VI lives in, and it gives you the name of the VI. So that's how you would then open a reference to the VI to do stuff with it. Why is there a 2 on the options for Open VI reference? So Open VI reference will give you a reference to a VI. Well, what if you give it a path or the name of a template VI? So I just used a template VI in my demo. I started with a quick drop plugin template, right? A VI that ends in a .vit extension. If you call OpenVI reference on a .vit and you don't wire that option 2, it's going to open a new reference to a new VI that is based on that template. Well, we don't want to do that here. We don't want to open a new VI reference. We want to open a reference to a template so that we can explore to where it lives on disk. So what that 2 does is that says, hey, if you're a template VI, don't make a copy of it. Open a reference to the actual template VI. That's why that 2 is there. You will see the option 2 wired to most OpenVI reference functions in most scripting tools that you work with. And then finally, why do we have an FP close at the end of this block diagram? Well, pull-down menu plugins have been around for a really long time, and whoever initially added them to LabVIEW, which was probably way before I started working with LabVIEW, they always had them show their panels when they're launched. So every pull-down menu item that you launch from the tools menu is going to show its panel, and then it's going to run. You don't necessarily need to do that with all tools. Some tools you do, but not all tools. The Explore tool, it doesn't have a useful panel. So we don't need to show its panel, but it gets shown anyway. So we need to make sure to close this panel when it's done. All right, next tool that I'm going to talk about is VI Analyzer tests. So VI Analyzer tests, you actually saw one in the previous presentation where it detected the tiny pixel-based VI. It's a way to inspect or modify various aspects of VIs. And we've got a screenshot here that shows several of the tests that ship with VI Analyzer. VI Analyzer is useful when you want to do bulk inspection or bulk modification of code. There is a web page for designing your own test. Again, link in the slides. There are over 100 tests that ship with the VI Analyzer toolkit. If you want to make your own test, you have to use the VI Analyzer toolkit. It creates the test for you and tags them in a certain way so the analyzer can use them. There are over 50 tests available for download from ni.com/VI Analyzer. Now, here's the thing about the and then there's a presentation available there as well that I have given. So here's the thing about VI Analyzer tests. This is an example of a VI Analyzer test. You can see it's very simple. I'll talk through the scripting code real quick. This test is called Convert Terminal View. So what this test will do is you can run this over a huge chunk of code, and it will go through every VI and any terminals on the block diagram that are set to terminal view, set to icon view. It's going to convert them to terminal view. This is for those of us that do not like the giant fat icon view of terminals, and we prefer the old style, smaller terminal view. So this code checks to see if the VI has a block diagram. If it does, we get all references to all the control terminals on the block diagram. For each one, we check to see if any of them are set to icon view, and if they are, we turn it off. And if we turned icon view off for any terminal on the block diagram, we call save instrument. So this is the thing that you need to be careful about. None of the VI Analyzer tests that ship with NI products modify your code. And that's definitely done on purpose. We don't want our bulk operation tool modifying your code. But there's nothing stopping you from writing VI Analyzer tests or downloading VI Analyzer tests that modify code. When you do, you have to be careful because we are now basically running an automated tool that is modifying our code base. So first of all, use source code control. Secondly, make sure you don't make a mistake like your code base is saved in LabVIEW 2017, but then you run this tool to convert terminal view with LabVIEW 2020, And now you've got pieces of your code base that are now saved in a newer version that you didn't want. So that's the kind of thing you got to watch out for. All right, so to summarize those 4 tools that I talked about, the main 4 ways to plug into the LabVIEW editor. Quick drop plugins you want to use when you've got a repetitive action performed dozens of times a day. Right-click menus you want to use when you have a context-sensitive operation. So I only want to do things on list boxes, or I only want to do things on while loops. One exception is things that are granular. For example, quick drop plugins are good for repetitive things, right? I create constants off of terminals dozens of times a day. I wish I could do that with a quick drop plugin, but I can't because quick drop plugins, they are limited by the selection boundary on a block diagram. You can select an add function. You cannot select the terminal on an add function, but you can right click on the terminal of an add function. So that's why a lot of the times repetitive actions, if they are more granular than selection, we need to make them right-click plugins instead of quick draw plugins. Pull-down menus are good for environment-based actions or document-based actions, and VI analyzer tests are good for bulk actions on multiple files, typically code inspection, which is what the VI analyzer toolkit does. Nothing stopping you from writing analyzer tests to do code modification. Any questions on any of those before I move into sort of a miscellaneous selection of editor hooks? All right, so miscellaneous hooks in the editor. I am not going to give demos about these. I am just going to mention them, and the slides have links to learn more information. Icon editor, y'all just heard all about this. You can replace the LabVIEW icon editor with your own icon editor if you want, and the link has instructions on how to do that. Whenever you do edit, create sub-VI, that is a G-based feature. You can completely replace the way we create sub-VIs if you've got a better way. You can also augment the way that we create sub-VIs by adding your own scripting code that runs after all of the scripting code for create sub-VI. The bookmark manager, you can replace the bookmark manager with one of your own. There is an example posted to ni.com where somebody wrote their own bookmark manager that not only shows the text of the bookmark, but also shows sort of the block diagram that is around the text whenever you select it in the list. You can add your own entries to the project templates, sample projects page whenever you do file, create project. DQMH adds its own, Actor Framework adds its own, DACMX adds its own, LabVIEW Realtime adds its own. If you have project templates that you have developed at your company that you want to show up in that list when you do file, create project, it's all documented how to do that. This is one that I only know of one person that's done. So whenever channel wires were added to LabVIEW, that was implemented as a plugin-based scheme. So LabVIEW ships with channel wire types like tag and message and all that stuff if you've ever worked with channels. Derek Bomarito is one of my former colleagues from NI, is the only person I know of who has written his own custom channel wire type. But if you decide that's something you want to do, that is another way to plug into the LabVIEW editor. All right, so the file new dialog, you can customize the content that appears there. Y'all saw in my demo, if you blinked, you missed it, but I did use the file new dialog to select a quick draw plugin as a template to create my quick draw plugin for the demo. What you can do is you can add a folder containing your VI templates, and you can add a text file to define the name of your folder that shows up in the file new dialog. And then you can add a diagram image to your folder of templates with that naming convention described in the slide. And when you do that, now your folder of templates will show up in the new dialog, not only with the VI templates, but also with descriptions and images next to them. So that is one way to customize the content that you see in the file new dialog. So you can also customize new class VIs. So when you do new accessors or new VI from dynamic dispatch template, that is all customizable. For example, if you decide that after you've created a new accessor, there's some additional scripting that you want to do afterwards, there's a way to do that. Probably the most common thing on this slide that I've seen people do is change the template name for new member VIs. Currently, if you just in regular LabVIEW, when you have an accessor called or when you have a private data called numeric, and you make new accessors for that, you'll get a read numeric.vi and a write numeric.vi. There are some LabVIEW teams that don't like the terms read and write, and so they like to replace that with get and set. And there is one VI where you go change a couple strings, and now anytime you make a new accessor, they'll be called get and set instead of read and write. If you, let's see, default names. Oh, I guess that's what I was talking about there, the get and set stuff. And then there's other things that you can change in there. I know a team that really likes the 5335 connector pane pattern instead of 4224. And so they went in and hacked at some of these VIs in this folder and made it so that their new class member VIs get the 5335 template. I would not recommend that because I personally don't like 5335, but that is another one of the things that you can do. All right, so I want to talk about custom probes real quick. Those are another way that you can augment the LabVIEW editor. Obviously, we have a help topic for creating a custom probe. And the thing is that you should never need to create a custom probe from scratch because there's so many great ones that ship with LabVIEW already. Whenever you create a new probe, one of your options is to start with an existing probe, and that's totally what you want to do. So in the slide, I've got a picture of the string history probe. One thing that I've done often is I'll be working on code that uses enums, and I want to get a history probe for that enum. Well, that's very specific to my code, right? Very specific to my project. Still, it takes literally 15 seconds to create a new custom probe based on the string history probe, drop a format into string inside of there to turn the enum into a string. Now I've got a custom history probe for my enum. It's extremely easy. So definitely when you're debugging, think about, debugging sometimes is hard, sometimes takes a lot of time. You can, in less than a minute, add a custom probe to LabVIEW that will probably help you with some of the probing some of the custom data types that you have in your code. Just something to keep in mind, something I want to be in the back of your head the next time you're debugging. There's also a feature in LabVIEW that nobody talks about called data agnostic smart probes. I wrote a Nugget post about it on the forums. There's a link in the slides. A data agnostic smart probe is a probe that's not tied to a specific data type. So you can create a data agnostic smart probe. We really need to come up with a shorter name for that. On any wire data type, you can see the picture on the right has the same probe type created on a Boolean, numeric, string, and path data type. That particular probe is used to gather timing information on the block diagram. You can see the one at the very bottom of the slide is a probe that was added to LabVIEW, I think in 2019 or 2020, called toggle execution highlighting, where you set the probe at one point on your block diagram, set another one at another point on your block diagram. Data types of the wires don't matter. When you run the code, execution highlighting will only turn on for that one section of code between the two probes. So pretty useful thing for data agnostic smart probes. I'd like to see some other people come up with some ideas for those. The two that you see in the slide are kind of the only ones that we've seen so far: timing things and toggling execution highlighting. So maybe some people have some good ideas for some other ones out there. All right, check it out. There's a new feature in LabVIEW 2023 Q3 that is a way to augment the LabVIEW editor, and that is called Quick Change. So if you have not tried 2023 Q3 yet, or if you haven't watched any of the videos like Tom McQuillan's video on new features, if you haven't seen this before, if you're typing in a free label on the front panel or on the block diagram, and you press Control Space while typing, so while you have editing in the free label, you will see the Quick Change window come up. This is going to list a whole bunch of things that you can convert that free label into. For example, you can see I have selected the string array option in Quick Change, which will turn my free label of strings into an array of string constant values on the block diagram. Super easy to utilize. When you download the slides, you'll see the path, or you can see it barely at the bottom of the screen there, for the template and the instructions for how to create your own quick change plugins in LabVIEW. Both the front panel and the block diagram are supported. So yet another way to hook into the LabVIEW editor that we just got in the most recent LabVIEW version. So pretty excited about that. All right, this is the part of the presentation where there will not be any links. There will not be any instructions from me on how to do these things. And the reason is that these are rusty nails. If any of you guys have ever heard of or met Greg McCaskill, he is a longtime member of LabVIEW R&D, working on making LabVIEW better for us for over 30 years. And he coined this term. He basically, when a word of scripting was first getting out years and years ago, it was not an official feature. People were sort of accidentally discovering it. And he basically went on the forums and said, you know what, guys? All these new fun little hidden, private, unsupported features y'all are playing with, these are like going up into grandma's attic. And there's all sorts of boxes full of cool stuff up there and maybe toys that haven't been played with in 50 years. But since it's the attic, there might be nails sticking up out of the ground that you might accidentally step on if you're not careful. And that is what these items in this part of the presentation are. I'm not going to tell you how to use them, but I did promise at the beginning that I would talk about every way to hook into the LabVIEW editor. So you are now going to hear about the parts of the LabVIEW editor that you could hook into, but you never should. First one is LV callback VIs. So if you have LabVIEW open right now, or if you have your laptop open, you can go into the LabVIEW folder and look in the resource plugins folder, and you will see several VIs with the prefix LV underscore. And what these can do is these can override behavior for certain editor actions. For example, when you press Control in and a new VI comes up, believe it or not, you could write an LV callback that overrides that behavior and has something else happen. Maybe it opens up a VI that already has some stuff on its block diagram, or maybe it, I don't know, opens up two VIs. Maybe it positions the windows of the VIs in a certain way. I don't know what it's going to do, but you could write code to customize that behavior. There's also an LV callback for Control Q. So when you press Control Q to exit LabVIEW, we could run a VI, and your VI could do something like pop up a prompt saying, "Are you sure you want to exit LabVIEW?" There's a lot of ways to plug into the LabVIEW editor with LV callback VIs. The issue is that this feature has been in LabVIEW since I was in elementary school. And as such, when LabVIEW was updated in LabVIEW 8.0 to have projects and libraries and application instances like we talked about before, this LV callback feature was not updated to account for that. So it has no idea what a project is. It has no idea what an application instance is. Normally, when you press Control in, if you had the My Computer selected in your project, it makes a new VI under My Computer. If you have an RT target, it makes a new VI under the RT target. If you write an LV callback to override Control in, that behavior is out the window. So this is why I avoid trying to customize the editor with these LV callbacks. The technology is too old and it's not context aware. Next up, you should avoid project providers. Now, what is a project provider? A project provider is a way to augment the LabVIEW project window with G-code. So if you look at that picture there, you can see that I have source code control enabled on this project. So I've got the little glyphs on my project items that tell me that these VIs are not checked out. I've got a right-click menu item to create a new actor. I've got a right-click menu item to launch the VI analyzer. Everything that you see in a red box in this slide is implemented with G-code. Specifically, it's implemented with a project provider. And so as you can see, it lets you edit the pictures in the glyphs. It lets you add items to the right-click menus. You should avoid project providers. Their documentation is spotty. The feature is not that stable. There's a lot of corner cases, and a lot of times NI has to fix your issue with your project provider because there's no way for you to fix it yourself. For example, I worked on a project provider where there was a bug, and the fix for the bug was to go through all of the code, right-click on the OpenVI reference functions, and select a hidden menu item on them to tag them in a certain way that only NI can do, that there is no scripting interface to do with. So if you write a project provider and you run into that same bug that I ran into, there's literally nothing you can do to fix it because you don't have access to those hidden right-click menu items that NI has. So that's just one example of many of why you should avoid project providers. All right, next up, you should avoid X nodes. What is an X node? An X node is a way to define a new block diagram object that behaves in ways that are much more advanced than just your typical sub-VI. For example, the match regular expression function, you can right-click on it to configure it. You can select grab handles on it to drag it up and down to add terminals. You would think that that is a built-in primitive in LabVIEW, but it's not actually. It is an X node. Somebody wrote G-code to provide all that functionality. The error ring is another example of an X node where you've got G-code that's implementing a block diagram that can do things like have drop-downs on it. You can see the growability, adding and removing terminals. When you wire a data type to it, you can have it act in a certain way to adapt to that data type. Lots of things you can do with X nodes. You should never write X nodes. Again, documentation is spotty. There's a bunch of corner cases. If you write X nodes and you try to use them with LabVIEW classes or PPLs, you can have build issues. They're mostly untested outside of NI-specific scenarios. You have to hack some licensing to get features added to the editor. I talk about Xnodes a lot more in a presentation I gave a couple of years ago at GDevCon NA called Ludicrous LabVIEW. So there's a link in the slide to learn more about Xnodes. There's a question in the chat. Does NI plan to remove rusty nails from project providers? I'm not in LabVIEW R&D anymore, so I can't speak to what their roadmaps are. I have not heard of any work being done on project providers other than trying to maintain them. And whenever teams internal to NI need to use them, obviously having to wade through the bugs to get them to work. All right, this next one, I'm sorry, you guys. I know X controls is an official feature of LabVIEW, but I think you should avoid them. They are a way to augment the editor by creating new panel objects for which you can define new right-click menus and new properties and methods. You can also define execution behavior that happens at edit time as opposed to at runtime. And like I said, you can add properties and methods. The problem is there's so many corner cases with X controls that I've seen. You write this really cool X control, it works great, you love it, you share it with people, they start using it in projects that become more and more complex. And ultimately, if there ends up being like build issues that you can trace down to problems with Xnodes. So again, it's an official feature, so I would suggest avoiding them. Thanks, Andreas, for the transition to my next slide, which is instead of X controls, you should be using Q controls. So Q controls provide almost the same functionality as X controls, not quite, but close. But the best part about them is that they are not built on top of X controls. They are built on top of LabVIEW classes and standard LabVIEW functionality. Q controls are an add-on to LabVIEW you can get from VIPM. You didn't steal my thunder, Andreas. You were the perfect transition to my next slide. Thank you. In the slide here, you can see pictures of several Q controls like the spell check string, the calendar control, it actually works good, the rich text string, the flex grid multi-column list box with different data types. Definitely, if you're looking to have a more rich set of controls, and if you're looking to augment the editor by writing your own rich controls, I highly suggest using Q controls instead of X controls. All right, that is it. 1 minute left for questions. Anybody have any questions that they want to ask me in the chat or unmute your mics? I'm happy to do so.
Thanks, Darren. That was awesome. Really interesting stuff in there. So yeah, really appreciate you sparing the time.
Certainly. Yeah. Any final questions or anything before I sign off for the rest of my day? I'm giving another presentation later today.
I don't think there are any.
Okay, great.
So, awesome.